Is the PPT visible to everyone? Can you see the terms written introduction to computer programming? Is it coming up fine, right? Okay, great guys, great. So yes, welcome everyone. Good evening, right? And a very, very warm welcome to the first lecture, right? So hopefully you guys are as excited as I am, right? So this is going to be our first lecture on, computer programming, right? So what is the idea behind today's lecture, right? What is the content that we are going to cover today? So today's class is a very basic and a very, very important class for all of you, right? So irrespective of whether you are coming from a computer background or you are coming from a, IT or a tech background, or you come from a non-tech background, today's class is going to be super important for all of you. Why do I say this? Because today we are going to cover some very, very fundamental and basic concepts that will help you to build on. Okay, so today we will be laying the fundamentals. And on top of the fundamentals, you will start learning the course in a gradual manner. Okay, so all the jargons, all the complex terms that you hear, all the basic concepts of computers that everybody should know. Okay, today I am going to discuss all those particular concepts. Okay, so let's get started, guys, without any further delays, right? So as the agenda for today states, introduction to computer programming. That is, we are going to learn about the fundamentals of computer programming today. Okay, so let's get started, guys. Okay, so if I want to understand this term computer programming, right? The idea for today's class is that we understand, that we want to understand this complex term computer programming. What do I exactly mean by computer programming? So guys, in order to understand this word computer programming, we can break this up into two simpler words. What are those two words? The first word is computer and the second one is program. Okay. So now if I understand these two terms, computer and program, then we will be in a better position to understand what do we mean by computer programming. Okay. So let's start, guys, with the first of the basic understanding of what a computer exactly is. Okay. So I ask you a question, what is a computer, right? And I am pretty sure that 95 to 96% of you present here, all of us, almost all of us have interacted with a computer at some point of our life or another, right? So computers are so ubiquitous, right? The technology around us is so advanced that all of us know what a computer is. And all of us have used a computer at some point of time or the other. Okay. But if I still ask you, hey, what is a computer? What is a computer? Okay. So in very simple terms, if I want to tell you what is a computer, I will tell you that, hey, you know what? A computer is an electrical machine, right? See, I'm just breaking it down into very, very simple terms, right? A computer may be much larger than that, right? But what we want to do is we want to understand the fundamental concepts. Okay. So a computer is nothing but an electrical machine, or you can also say that a computer is an electronic device. Okay. So boss, what is a computer? A computer is a very basic electrical machine, or it is an electronic device. Okay, understood what a computer is. Now I ask you, what is a machine? Hey, you will ask me, hey Adarsh, you told us that computer is an electrical machine, right? But what is a machine? Okay, so now we come to the question that what is a machine? What is a machine? Hey Adarsh, you just now told me that a computer is an electrical machine, but what do you mean by a machine, right? So I don't know. See, I am not a very big fan of, word-to-word definitions, right? And I am very bad at remembering things also, right? So that is one pain point you have to deal with me, right? So, I don't know how many of you have watched the movie Three Idiots, right? I am pretty sure a large number of people have watched the movie Three Idiots, right? So there I remember that in a particular class, a professor asks Amir Khan, what is a machine, right? Or something like that. And Chatur gives a very, very complex definition of what a machine is. So thankfully, I won't be boring you all with a very complex definition of what a machine is, right? So I'll be the, Amir Khan of your story, and I will give you a very, very simple definition of what a machine is, right? So what is a machine, guys? A machine is anything that reduces human effort. Okay. So machine kya hua? A machine is anything that helps to reduce human effort. A machine is a device or an instrument that makes your life easier. It helps to reduce human effort. Okay. So now you will ask me, hey, you told that a computer is a machine, but how does a computer help to reduce human effort? Can you please give some examples of how a computer helps to reduce human effort? So let me take a couple of examples to give you an understanding of how computers help to reduce human effort. Okay. So guys, if I give you two numbers to add, let's say I tell you, hey, can you tell me what is 2 plus 5? Everybody will instantaneously give me the answer that, hey, others, 2 plus 5 is 7. Okay. If I ask you what is 88 plus 12, everybody will tell me instantaneously that the answer is 100. But what if I give you two very, very large numbers? Let's say I give you, hey, can you add 7, 8, 4, 5, 3, 2, 2, 1, 0, 0, 1, 0, 5, 8 plus 6, 4, 3, 2, 2, 1, 0, 8, 5, 8. I am pretty sure nobody followed me. And मैंने बोला भी ऐसे कि you wouldn't follow me, right? But what I want to tell you all is, let's say if I give you two very, very large numbers, so you will not be able to add those two numbers and give me the answer instantaneously. You will take some time, right? You will take a piece of pen and paper, write the numbers, perform addition, and then give me the answer. So you will take some time and you won't be giving me the answer in a fraction of a second, right? Aapko time lagega. Okay. If you are more intelligent, what you will do? You will take a piece of calculator, enter the numbers, form the addition, and give me the answer instantaneously. So what have you done, guys? You use the calculator to make your life simpler so that you don't have to do the complex calculations. You used a calculator. And what is a calculator, guys? A calculator at the end of the day is also a computer, right? So a calculator is also a computer or a machine that helping us to reduce human effort. So this is one very practical example of where we use this, mobile calculators or, the mobile computers. Okay. So, calculator is also an example of a computer that helps you to reduce human effort. But let me take another more practical example. And I'm pretty sure that all of you will get convinced with this, right? So let's say if you have the marks of, hundreds and thousands of students, right? And if I ask you, hey, can you give me the average marks of hundreds and thousands of students, right? You have the entire mark sheet of hundreds and thousands of students, and you want me to give the average of those marks, right? So obviously using a pen and paper, it will take a large amount of time and, probably I will sleep by then, right? So what will you do? Guys, in normal situation where you have a large load of data, okay, where you have a large pile of data to process, what do we generally do? I am pretty sure all of you have heard this Excel, Microsoft Excel. So what do? You feed your data in Excel. Okay, I will put the student name and the marks in Excel. And then with the click of a button and with some formulas, we will get the average marks of the students. We can get the highest marks. We can get the lowest marks. We can sort the students in alphabetical order. All these manipulations on data we can do almost instantaneously. Okay. So what I want you guys to understand is when we have a large chunk of data to process, manual processing is a very, very slow task. So what do? You tend to use computers and softwares inside the computer, right? So MS Excel is a very, very popular example where you feed your data and then within the fraction of a second, you can get analysis on that data. You can perform operations on that data, right? So that is how, guys, with these couple of examples, I am pretty sure all of you agree that yes, a computer is a good machine that helps us to reduce our effort. Great. A computer is a very, very good friend of ours, right? But now what happens is every coin has two sides, right? So there are certain pros of a computer as well as there are certain cons of a computer. So let's see what are the plus points or the advantages of a computer. Okay. So I will tell you, hey, what are the two pros of a computer that I can think about? One is definitely it is making our life easier, right? It reduces our efforts. Our human effort is reduced a lot because of computers, right? So the first pro or the advantage of a computer that I can think of, what is it? It performs very fast computations, right? So whatever calculations you give to the computer, very, very complex calculations, complex computations, large amount of computation, right? It can do it in a fraction of a second. Very, very fast processing power. All the computers do computations very fast and give you the answer. What is another pro of a computer? Guys, computer give you storage. Okay. So whenever you do some data analysis or do any operation in the computer, right? You can store your information inside computers as well. So a computer has storage and you can store your important files, important information, and all these things in a computer. So storage is a very, very important point of a computer because we can store our important information and later on when we want to retrieve, we can get it from the memory. So these are the two very, very important plus points of a computer. Okay. But as every coin has two sides, there is a big con associated with a computer as well. And guys, this con is a blessing in disguise for us, for people like you and me. So let me tell you what is the con. The major con of a computer is that a computer is an extremely dumb machine. A computer is an extremely dumb machine. It doesn't know anything of its own, right? You have to explicitly tell the computer what to do. आपको explicitly instructions देना पड़ता है computer को कि what do you want the computer to do. So think of it, guys, that a computer is your slave and you are the master and you want to exactly tell the computer what to do. You have to give explicit instructions to the computer on how it should respond in scenarios. What should the computer do? The computer has no brain and no intelligence of its own. It is a very, very dumb machine waiting for your instructions. And guys, this is a blessing in disguise because we as programmers will be providing these instructions to the computer. If the computer would have been an intelligent machine, then वो सब कुछ खुद कर लेता. We wouldn't be in the picture, right? But because a computer is a dumb machine, people like you and me have jobs, right? I have a job and you are going to land up a job very soon, right? So guys, because a computer is a dumb machine and it requires explicit instructions, people like you and me have our jobs, right? So yes, treat a computer like your slave, and whatever you tell the computer, it will do exactly that. It doesn't have any brain of its own. So this is the pro and con of a computer. Okay. So with this thing, I feel that you have got a pretty decent idea of what a computer exactly is, like what are computers, right? Now let's come to the second word, program, right? Now let's come to the second word, program, right? So what is a program, guys? I will just interlink it to the previous discussion. Okay. So I have a phone alongside with me. Okay, just 1 second, 890. Okay. So I think let me finish up for some time, right? At least 15-20 minutes. And then I can open up for discussion as well, right? And yeah, even I don't remember the topics exactly. So jaise flow mein chalega, I'll try to cover it, right? So it might not be a very structured, but I'll try to make it as interactive and as interesting as possible, right? So now let's come to what a program is. What is a program, right? So just now I told you that the computer is a dumb machine and you have to explicitly give instructions to the computer what to do. And aapko instruction dena padta hai. So what is this instruction? This instruction is a program. So what is a program, guys? If I want to give you a simple definition of what a program is, I will tell you, boss, a program is nothing but a set of instructions. Okay. A program is a set of instructions that tells the computer what to do. Okay. So guys, because a computer is dumb, you have to explicitly command the computer or give instructions to the computer of what it should do. So the set of instructions that you give to the computer, see, you will be writing these instructions and you will be giving the instructions to the computer. So the set of instructions that tells the computer what to do, that is known as a program. A program is nothing but a set of instructions. So think of it like, you have written instructions and these set of instructions that you have written, this is nothing but a program. Okay. So where do we exactly fit into the picture? Where do we as programmers fit into the picture? Guys, people like you and me, programmers, what we will be doing? We will be writing these programs, right? So we are the actual brain behind the computer, okay? So we will be writing instructions as programmers, right? We will be writing programs that tell the computer what to do and how to respond, okay? So software developers are people who write programs that will be giving instructions to the computer of what the computer has to do and how it has to respond in a certain situation. So that is what a program is, okay? Now you will ask me, hey, Adarsh, you told that the computer is a dumb machine, right? And you just now told that we have to explicitly tell the computer everything on our own. Otherwise, the computer is as good as a dumb machine with no capabilities of its own, right? But you will tell me, hey, Adarsh, I have interacted with a computer multiple times and I did not have to tell the computer what to do. Mera computer to bahut intelligent hai. Whenever I want to send a mail send ho jata hai. Whenever I want to play a game, I can play a game on a computer. I never had to give instructions to the computer. So guys, let us see what exactly happens. So let's take the case of a mail, right? You want to send a mail to your friend, okay? So let's say you are person A, okay? And you want to send a mail to another person B. So what do? You open up the computer, you open up the mailbox, you then type in a mail. Hey, how are you doing? And after typing in the mail, you hit the send button. There is a send button and you click on that. The moment you click on the send button, within a fraction of a second, the mail gets delivered to the mailbox of person B. So you will tell me, hey, Adarsh, my computer is very intelligent. I did not have to tell the computer how to send the mail and what to do. अपने आप ही mail चला गया. मैंने तो सिर्फ send button दबाया. Guys, computer is not intelligent on its own. What actually happens is, what you are missing is, behind the picture, there are software developers like you and me who have already written instructions for the computer. They have written programs for the computer. And they have explicitly told the computer that, hey, when somebody presses a send button, do these things, do whatever, and send the mail to person B. So guys, software developers have already written programs in the backend that actually run when you hit the send button. So as soon as you hit the send button, this set of instructions that the software developer has written, that will come into the picture and the computer will, run according to these sets of instructions, and then the mail will be sent to person B. So for the end user, right, for this person A, using a computer is very, very simple and he doesn't have to give instructions. But what you should always remember is, behind the scenes, there are people known as software developers who have written explicit instructions on how the computer has to respond if this send button is pressed. So आपके लिए बहुत easy लग रहा होगा. For person A, the situation is very simple. But people like you and me, software developers, have actually written all the instructions of how the computer has to respond. Similarly, guys, take another example. Let's say you are playing a game on your personal computer. On your PC, you are playing a game, right? And let's say the game is NFS, Need for Speed. I don't know how many of you have played it. I played it a lot. It's a car racing game, right? So let's say when you press the left key, the car moves to the left. When you press the right key, the car moves to the right. When you press the space bar, the car stops, right? So you will tell, hey, Adarsh, I am able to play the game. I am able to enjoy the game. मेरे को तो computer को कोई instruction नहीं देना पड़ा. I didn't have to give instructions to the computer. I'm able to enjoy the game. But guys, what I will tell you is the people who have developed the game Need for Speed, right? The software developers have already written instructions for this particular application that, hey, when the user presses the left key, move the car left to, let's say, 5 degrees. When the user presses the right key, move the car to the right by 5 degrees. When the user presses the space bar, please reduce the speed of the car by 20 units, something like this. So all the sets of instructions have already been written by software developers. And because of these people who have written instructions already, you are able to so freely interact with a computer. So that is where we are fitting inside the big picture. सबको यूज करना बहुत easy लगता है computer, right? You find it very easy. You open a Swiggy app, you place an order, get food instantaneously. Everything looks so easy. But there is an entire team sitting behind who has written instructions on what to do when an order is received, how to forward that order to the restaurant, how to assign a delivery partner. All these rules are written by software developers. So that is where we are fitting inside the big picture. Okay. So I think I'll take a liberty here to just ask you all how the flow is going. Yes, guys, I've opened up the chats for you all. So are you able to follow along? Is the flow clear? Are we getting where we are going towards? Sahi hai, pace sahi hai? Not going too fast, not going too slow, right? Okay, cool. I think everyone is fine. Yeah, the class is basic, guys, okay? The class is basic. Today's class is nothing very fancy and hard and fast, right? आज एक पूरा एक base आप लोग का बनाना है, one solid base, so that you can build on top of that. You should know what you are studying first of all, right? Okay. So now we know that what a program actually is, right? And we are the people who are writing instructions for the computer to understand how it should actually respond. Okay. So now I say, okay, so you have to communicate with the computer, right? You are the master and you have to give instructions to the computer, right? So I ask you, in what language do you talk to the computer? आप किस language में computer के साथ बात करोगे? Do you speak in English with the computer? Do you talk with the computer in Hindi, or do you give instructions to the computer in whatever language, right? So what I tell you guys is we don't give instructions to the computer in English, Hindi, or whatever, right? Why? Because see guys, the languages that we use to communicate now, they are very, very ambiguous language. English is a very funny language, right? I don't know how many of you have seen the movie Bol Bachchan, right? Abhishek Bachchan tells there, right? English is a very funny language. You can talk English, walk English, and whatnot, right? What I mean to say is, एक English sentence का ना, there can be different interpretations. Okay, if you see a sentence in English, different words can mean different things. Okay, when I say the same thing in different tones, I can sound different. Okay, the same sentence, if it is said in a sarcastic tone, that means different. If the same sentence is said in a happy tone, that means different, right? So, boss, English is a very, very funny language. Words have different meanings, right? You can interpret the same sentence in different ways. So, boss, English cannot be used to give instructions to the computer, because computer as it is a very, very dumb machine. You have to give it very, very precise instructions, and English is a very, very ambiguous language, or any other language now is also ambiguous. I might know English, but a person in some other part of the world might not know English. So there has to be some standard language of interacting with the computer. And what is that particular language? Okay. So guys, if you talk about what a computer actually understands, right? So a computer at the end of the day only understands binary language. Okay. Binary language or machine code. These can be used interchangeably. So a computer understands a binary language or a machine code. What do I mean by this? See guys, a computer is an electronic device, right? So it consists of transistors, semiconductors, and capacitors and all those things, right? So because it is an electronic device now, a computer only understands binary language or machine code. And a binary language is a language that is consisting of only zeros and ones, right? So there are only two possible options. Either you have a zero or you have a one. So computers understand only stream of zeros and one. Okay. So you will give a stream of zeros and ones, 0, 0, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, whatever, right? So a stream of zeros and ones is something that a computer understands. And this we call as a binary language or the machine code. Okay. So zero basically stands for uncharged. Okay. So because you have capacitors and everything now, there are two states inside a computer, discharged and charged. Okay. So zero is uncharged and one is charged, right? So, but what I want you guys to understand, or the take home important piece of advice here is, a computer only understands zeros and ones at the end of the day. It understands only binary language or machine code that just consists of zeros and ones. Okay? So if you give an instruction in zeros and ones, the computer will understand and do whatever you have asked it to do. But now guys, I tell you, okay, computer understands machine code or zeros and ones. तो हम लोग को zeros and ones में instruction लिखना चाहिए, right? A computer only understands zeros and ones, so we should also give instructions in zeros and ones. But guys, it is very difficult for human beings like you and me to write instructions in zeros and ones, right? It becomes very confusing as well, right? Looking at a file full of zeros and ones, सोचो क्या होगा? Everywhere you see only 001, 00000011111, all these things, right? It will be very, very difficult for people like you and me to write code in binary. We don't do that, right? Very difficult to write, very difficult to maintain, very difficult to debug. So we don't write code in binary language. We don't write code in binary language. So then I ask you, what language do we write instructions in? I am not writing programs in binary language. Then what language will we be writing our programs in? So guys, we generally write whatever programs we write in something known as HLL. And what is HLL? HLL is basically high level languages. Okay. So whatever instruction we have to give to the computer, right? We give it in a high level language. What is a high level language? A high level language is closer to us than closer to the computer, right? So a high level language kya hota hai? It is not ambiguous, right? It is a very, very precise language. All those things are there, right? But it is very, very simple for human beings to write and understand high level languages. That is what I mean when I say high level languages are closer to us. We can understand it easily. It is more close to us than closer to the computer. Okay. So we write whatever programs or instructions that we have to give in something known as high level languages. And what are some examples of high level languages? Some examples are C++, Java, Python, okay, Golang, multiple languages are there, right? So all these are examples of high level languages in which you will be writing programs or giving instructions to the computer. Okay. So now we understood that yes, we are human beings and we will be writing, the instructions in high level language. But guys, do you sense a problem here? I sense a problem. What did I tell you? I told you that the computer understands only binary or machine code, right? Computer ko khali yahi samajh mein aata hai, stream of zeros and ones. And what I am telling you is we are writing the code in high level language. Okay. So guys, before I come to this, let me tell you one simple thing. In this course, we are going to write our programs in Java, right? Java is the high level language that we have selected. Okay. So what is the reason behind choosing Java? Why do we use Java in this course? There are a couple of reasons, right? First of all, Java is a very widespread use language, right? In the entire industry, there are many companies, many people, almost all companies use Java very, very frequently. So the demand for Java language is very huge, right? And there are a lot of opportunities coming in Java. So that is one of the major reasons of keeping the course in Java, right? Apart from that, some good traits of the Java languages, it is a very fast language, right? Fast. It is very fast language, okay? The second and the important part is, what? Java is a very, very secure language. Okay, it is fast and it is a very secure language. How it is secure? It is secure because of OOP principles. Okay, so Java is an object-oriented language. What is this OOP? OOP means object-oriented principles. Okay, so guys, don't worry about all these complex terms. You will learn about OOP in module 2, right? When you get integrated with a Pioneer batch, all these things will be taken care of. Okay, but Java is a very secure language. Why? Because Java is built on the principles of object-oriented programming, right? Java is an OOP language. Okay, so that is why it is very, very secure. And everybody wants secure languages in today's world, right? Because nobody wants a data breach or a corruption to happen, right? So Java is a very, very secure language and it will protect all your information properly. How does it able to do that? Because of OOP principles, object-oriented programming principles, right? And the third and a good point of Java is it is a portable language. Okay, it is a portable language or it is basically platform independent. Okay, more about this in today's class only. But these are the 3 good points of Java that I can think of at this point of time. Java is a very fast language. It is a secure language because of OOP principles, and Java is a portable language. It is platform independent. I will tell about more details on this point a little bit later. Okay, so that is why, guys, we are going to study this course in Java. Okay, now, as you might have understood, there is a small problem in the entire story that I have been telling you till now, right? I told you that the computer understands binary or machine code. And I also told you that you are writing instructions in HLL. So guys, do you agree that there needs to be an entity? There has to be someone in between who converts this high level language into binary or machine code so that the computer is able to understand. Boss, try to think of this. Let's say you have gone on a foreign trip pe gaye ho aap, okay? And you only know English. Okay, आपको सिर्फ English आता है, right? And the people of that country, let's say they only know Arabic, they only understand Arabic. So guys, if you tell anything in English, will these people be able to understand what you are telling? No. So whatever you want to communicate, nothing will get understood by these people, right? So you will be giving instructions or you might be asking, these people something, but because they only understand Arabic, they won't be able to respond you back. Okay, and any form of communication or any instructions that you want to give, you will not be able to give. So who will come to you to help in this situation? Google Translate or a translator, right? So there will be a person known as a translator. Please forgive my drawing, right? This translator is having 3 feet apparently, but forgive my drawing, right? So there will be a person known as a translator, and what will that translator do? The translator will convert your English into Arabic so that this person can understand and he can process your request, or whatever you are telling, he can respond back to you. Okay. So a translator is very important if you want to convert or you want to basically communicate with some other people, right? Similarly, we are writing code in HLL and computer understands binary. So there is a gap created in between. Who will convert this HLL into binary so that computer can understand? So guys, we have entities known as compiler. A compiler, think of a compiler like a translator. Okay. It will convert the high level language into machine or binary code so that the computer is able to understand and able to execute the instructions, right? So this entity can either be a compiler or it can also be an interpreter. I will talk about these in more detail as we go along, right? But think of it like a compiler or an interpreter is an entity that converts the high-level language into binary or machine code. The process might be more complex than this, right? But we want to get a basic idea of the terminologies, the different terms that we will be, we keep on listening in the course, right? And what is the overall high-level picture that we want to understand. So a compiler or an interpreter, I will tell you the difference also between these two. But for us, understand it like this, that a compiler or an interpreter is something that converts the high-level language that we write into machine code so that the computer is able to understand whatever we are instructing it to do. Okay. So that is where we come to the idea of a compiler. Okay. Now, once you understand what a compiler or an interpreter is, right? I will tell you what is the difference also a little bit later, right? But now let us try to understand how exactly the process of conversion happens in Java, right? See, in general, the process is not as simple as from HLL, it will go to binary or machine code, right? In general, it happens like this. Boss, a compiler or an interpreter will convert the high-level language that you write into a stream of zeros and ones, that is the binary or machine code, so that the computer is able to understand. But how does this entire conversion process actually happens in Java? Let us try to understand that. And with that, we will also understand why is Java a portable or a platform-independent language. Okay. So guys, what happens in Java is, let's try to understand the conversion process in Java. Okay. So you will be writing your code in high-level language, right? So you will be writing whatever code you write or instructions you write, right? And you will be saving your files as .java files, right? So let me call it as demo.java. Let's say you create a file and you store it by the name of demo.java, right? So the Java file in which you write your program now, that we call as the source code. This is the source code. Okay, whatever source code is there, you have written in this particular file, right? So whatever code you write in your .java file, that is known as the source code, okay, or the high-level language code that you have actually written, okay? So we have .java files in which we write our high-level language, okay? आपने पूरा code लिख दिया, and we call this code as our source code. Now what happens, guys? Now what happens is there is something known as a Java compiler, right? Java has a compiler, right? So हम लोग क्या बोलते हैं? Let's say we'll say something like this: Java C. See, all these things we don't have to do. I am going very detailed and telling you how exactly things happen in the backend. But you will see that we don't have to worry about all these details. And for us, the code will run with a single click of the run button. Okay. But what happens is there is something known as a Java C. Think of it like the Java compiler, right? So I write Java C, this thing, whatever is the name of the file, Java C demo.java. So what happens, guys? When I say Java C demo.java, what happens? The compiler, the Java compiler will act upon this demo file. And what will happen? The high-level language will get compiled, or the compiler will convert the high-level language into something known as a bytecode. Okay. The compiler converts the high-level language into something known as a bytecode. And how does the bytecode look like? You will have .class files. Okay. So let's say demo.class, a.class, b.class, right? So your bytecode is an intermediate form of code between HLL and between binary, right? So ये HLL से नीचे है, but it is not binary code, right? So the compiler acts and converts the high-level language into something known as a bytecode, right? And you will see many .class files being created, right? So demo.class, a.class, b.class, all these things will happen. Now, guys, this bytecode that has been created, right? This is portable, okay? So this bytecode is extremely portable. What do I mean when I say this bytecode is portable? You can take these .class files on any machine that you want, right? If you want, you can take this .class file on a Windows machine, on a Linux machine, or any platform that you want, right? So this bytecode that you have get after compilation, you can take it on any platform and then you can execute this bytecode there. Okay? So आपने high level language को compile किया पहले, you get a bytecode. And then this bytecode file, which is a .class file, right? You can take it on any processor, any machine, right? You can take it anywhere, right? And what will happen is, guys, then when you take these .class files and you run it on any platform, what actually happens is this bytecode will then get converted into machine code or binary. So what happens, guys, is let's say you take this bytecode, that is the dot class file, and you place it on your platform, whatever machine you want to run it on, you place it, right? And then there will be something known as a JVM. What is JVM? See, guys, I am just giving you an overview picture, right? We don't want to go into the complexities of what is JVM, what is JRE, what is SDK, JDK, all these things. No. सिर्फ अभी बेसिक समझने का ट्राई करो, right? So when I take the bytecode on a platform and I run it, what actually happens is there is something known as a JVM on the platform. What is JVM? JVM is Java Virtual Machine. So what it does is the JVM will execute, the JVM will interpret the bytecode line by line. So let's say you have a bytecode. This is my bytecode. You take this bytecode on a platform and you run it. So what will happen? There will be an entity known as JVM on the platform, right? The Java Virtual Machine. So the JVM will basically interpret this bytecode line by line and it will run it. Okay. So the bytecode, JVM basically interprets the bytecode so that, see, JVM kya karega? JVM will interpret the bytecode line by line and convert it into machine code so that it can be run by the computer. Okay. So if I want to summarize what we have been talking about is in Java, first of all, you write the high level language code in your .java files, and that we call as the source code. Then when you write, let's say Java C demo.java, so first of all, high level language that you have written, that gets compiled into something known as a bytecode. Okay. Now this bytecode actually consists of the .class files. Okay. .class files, right? So now this bytecode is platform independent. It is portable, right? You can take this bytecode on any platform. Aap ye sare files, you can take it on any platform. And when you run these files on a platform, what will happen? An entity known as JVM will interpret these line by line. Okay. So the bytecode will be interpreted line by line and it will be converted into machine code so that your computer can execute your instructions. Okay. So that is why Java is a platform independent language, because ye jo bytecode hota hai na, this bytecode is very portable. You can take it on any platform and you can run it, right? So you can compile your code into bytecode on any platform, and then you can take this bytecode and run it on any other different platform as well. So that is why we say that, hey boss, because of this bytecode, right? Java is a platform independent or platform independent or portable language, right? That is the particular reason. So now you will tell me, hey Adarsh, can you please tell me the difference between a compiler and an interpreter, right? You told us that there is either a compiler or an interpreter. So what is the difference between a compiler and an interpreter, right? Let us try to understand that with an example, okay? And then we'll understand. So ध्यान से समझना guys, HLL to bytecode, a compiler is working, right? So compiler compiles the high level language into bytecode. And then when the bytecode is run, what happens? JVM will interpret the bytecode line by line and convert it into machine code. So Java is both compiled as well as interpreted. ध्यान से सुनना guys. Java is both compiled as well as interpreted. Okay, this first part of HLL to bytecode is compilation, and from bytecode to machine code, that is interpretation by the JVM. Okay, so Java is both compiled as well as interpreted. Now let me give you the difference between a compiler and an interpreter. You will tell me, hey, what is a compiler? What is an interpreter, right? Let me give you an example, right? So guys, if I talk of a, let's say, if I want to show you the idea of a compiled language, right? Java is compiled as well as interpreted, right? So for compiler, I will try to take example of Java. Java is a compiled language, right? इसमें compilation का process होता है. And guys, a purely interpreted language is Python. Python is a purely interpreted language. So let us try to understand what is the difference between a compiler and an interpreter. Let me, okay guys. So, what I'm telling you is, see, definitely write it right. So what I'm telling you is this line number 12, right? This is a valid line, not a problem, right? Then let's say this thing, okay? Line number 13 is not a valid line. Ye kharab line hai, right? This is not a valid line. Similarly, let's say you have another valid line, I, okay? Just I'm telling you the difference, that is why. And let's say you have another yo. Okay. So guys, what I'm telling is line number 12 and line number 14 are correct lines, right? But line number 13 and line number 15 are not correct lines, right? They are wrong lines. Kharab line hai. They won't do anything, okay? Line number 12 and line number 14 are good lines. They will be printing something or doing something, right? I don't know. But line number 13 and line number 15 are wrong. They are wrong. They don't do anything, right? So when I run this program, what will happen? Because this is a Java code, right? See main.java. What did I tell you? Whatever code that you write, you will be writing it in .java files, right? So when you click the run button now, first the compilation will happen. And once the compilation has happened successfully, interpreting will happen and the code will run properly, right? So let's try to run it and see what happens, right? So guys, what does a compiler do, right? A compilation में क्या होता है ना? The compiler basically compiles the entire code at once. So देखो guys, ये जो पूरा code मैंने लिखा है ना, this entire code, this will be compiled by the compiler. The compiler will try to compile this entire code into bytecode, ठीक है? So this line is good, no problem. this line is not a good line. So the compiler complains. This is a good line, no problem. This is a bad line. So the compiler complains, right? So a compiler compiles the entire program at once. पूरा compilation का task एक बार में होता है. And because the compiler tried to compile my entire code, it has told me that, boss, there are two problems. See, it has told me at line number 13, there is some problem. Okay. My compiler compiles the entire program and then tells me whatever error it gets at different places in the program. So all the errors are reported at once. See, and it also tells me at line number 15 also there is a problem. And I didn't see any output, right? See, it told me that the compilation failed. So the program did not even run. Okay. So what I want you guys to understand is what happens is, if my program is compiled now, the compiler will first of all try to compile or convert all the lines into bytecode, right? Sabse pehle, all the lines of the code will be compiled, okay? And if it gets any errors, now all the errors are reported at once. So wherever the compiler sees an error, it will tell you that, hey, there is an error on line number 13. There is an error on line number 15. So a compiler will compile your entire code at once and it will report to you all the errors that it sees in your code, right? And it will not run the code. The code doesn't run until you have resolved all the errors. See, hello world was not printed, right? Let's assume that line number 12 is printing hello world, but you don't see a hello world here, right? So a compiler kya karta hai? Compiler will scan the entire code and first of all see what all are the possible compilation errors. It reports all the compilation errors together. And once you have resolved all the compilation error, then only your code will run. Now see what happens. Let's say I resolve these two errors. I just remove them, right? For my understanding, let's say I remove these two. Okay, I simply remove this. Now my program is fine, right? So now when I will click the run button, what will happen? Internally, first of all, the compiler will act and it will convert the entire HLL into bytecode. Pura compilation proper hoga, right? And after the code has been compiled, the JVM interpreter will come and interpretation will happen line by line and you will see the output here. So if I run it directly, you will see the output because compiler doesn't raise any error and JVM will start executing the lines one by one. Okay, so you will see hello world and hi getting printed. Okay. So compiler kya karta hai, guys? It compiles the entire code, whatever you have, and then it gives you all the compilation errors at once. And it doesn't run the code until your errors have been resolved. So compilation happens at once. Okay. And once your code has been compiled properly, then the interpreter in case of Java will interpret it line by line. So first hello world is printed, then hi is printed. Okay. But if I want to give you a contrast of an interpreted language, what happens in the case of an interpreter, right? So let me talk about Python online. Interpreter, right? So Python is an interpreted language, right? See, they are writing an online Python compiler bracket mein interpreter, right? So what does an interpreter do? Let me try to give an example and then you will understand, right? So let's say I'm doing the same job, right? So let's say print D, low, okay? Again, I say print I, okay? So line number 3 and line number 5 are valid lines that do something, and line number 4 and line number 6 are bad lines that don't do anything, okay? Now when I run the program, Python is a purely interpreted language. So interpreter will come into the picture and it will interpret line by line. So pata interpreter kya karta hai? Interpreter basically works at runtime. When you run the program now, what will the interpreter do? The interpreter will first interpret line number 1. It will interpret this line, convert it into binary, run it. Then it will interpret this line, convert it into binary, run it. ऐसे करके होता है. Line by line the interpreter works. It doesn't tell me all the errors at once. अब देखो क्या होगा? See the magic. See the good. It is a bad thing actually, not a bad thing, it depends, right? So what has happened, guys? See, when I ran, because it is an interpreter starts interpreting line by line. And when you run the program, now the interpreter will start interpreting the lines at runtime, right? So when I run the program, this first line will be interpreted by the interpreter and it is converted to binary, and see this line runs and hello world is printed, right? Then the interpreter comes to line number 4. It interprets this particular line and sees that there is a problem with this particular line. So it immediately tells me that line number 4 has a problem and no other lines are executed. So see guys, the interpreter will error out wherever it sees an error during running of the program. See, I didn't get an error for line number 6 now, hai na? Interpreter kya? Interpreter has worked line by line. So जो line सही से run हो गया उसको run कर दिया. And the moment the interpreter sees that there is a problem in interpreting the particular line, the interpreter will stop executing the program and you will get the error. So see, interpreter works line by line and a compiler was working on the whole. Compiler kya kar raha tha? It was compiling the entire program and reporting all the errors at once. And then only the program ran. But an interpreter interprets line by line when you run the program. So the first line interpreted, converting to binary, running. Second line interpreted, problem, error out and stop the program. So that is the difference between a compiler and an interpreter. Okay. So now if I see, now if you resolve this error, let's say remove the line. Okay. And now if you run it, you will see hello world and hi getting printed. But again in this line, the interpreter will complain. Now if you remove this line, then your program will run properly and you will get hello world and hi. Okay. So that is the difference between a compiler and an interpreter. And generally, guys, it is a rule of thumb, right? कि compiled languages are faster than interpreted languages, right? Because an interpreter क्या करता है? It does it line by line. Okay, it will convert this entire line into binary, interpret it, convert it, right, at runtime. And whenever it gets any problem, it will stop. Okay. On the other hand, when you compile programs, what happens? The entire program is compiled at once, right? So all the errors are reported, and then you can resolve it and run it in a quicker time. Okay. So generally, the process of compilation is faster than the process of pure interpretation. Okay. So interpreter क्या करता है? If I want to summarize, interpreter at runtime, when you run the program, interpreter will work line by line. It will interpret the line, convert it into binary, and it will run it. Okay. The moment the interpreter sees a problem, it will stop executing the program. So interpreter doesn't report all the errors in the program at once. No, the program is running, and wherever it sees a problem while interpreting the line, it will tell you. On the other hand, when you compile a particular program, what particularly happens is the entire program, the compiler compiles that entire program into binary or machine code, right? In case of Java, it is different, right? But I'm telling you a general compiled program. When you compile, the program will be converted into binary code, and all the errors the compiler will report at once. जहाँ पे भी error होगा, the compiler will tell you. It will not run the program until all the compilation issues are resolved. Once you resolve all the compilation issues, the compiler will convert the entire program into binary, and then that binary will be running. Okay. But in case of Java, it is both compiled as well as interpreted, because from HLL to the bytecode, that is compilation, and from bytecode to machine code, that is your interpretation. Okay, cool guys. So जितने देर में वोट कास्ट कर दो, जितने में मैं रिकैप कर देता हूँ, ठीक है, 2 मिनट में, ठीक है. फॉर फोक्स हु वांटेड हिंदी में रिकैप ले लो यार, चलो अभी आई कैन हेल्प यू विद 2 minutes, right? So basically, let me tell it in both the languages only. I'll take 5 minutes, right? So we started off with the introduction to computer programming, and we understood what is computer, and we talked that yes, a computer is an electrical machine or a device that helps in making our life simple. Okay, so basically guys, computer क्या है? कंप्यूटर एक मशीन है जिससे मेरा लाइफ सिंपल होता है, ठीक है. कंप्यूटर मेरा बहुत वेज में हेल्प करता है, मेरा टास्क को बहुत इजी कर देता है, एंड इट बिकम्स वेरी वेरी सिंपल फॉर मी, राइट. एंड व्हाट आर द गुड पॉइंट्स ऑफ अ कंप्यूटर? दैट इट परफॉर्म्स कैलकुलेशंस वेरी फास्ट, इट हैज स्टोरेज, बट द कॉन इज दैट इट इज अ डम मशीन. मतलब कंप्यूटर कैलकुलेशन बहुत फास्ट करता है, स्टोर भी करेगा आपके लिए इन्फॉर्मेशन, बट कंप्यूटर है बेवकूफ, ठीक है. आपको सब कुछ कंप्यूटर को खुद से बताना पड़ेगा, जैसा बोलोगे वैसा करेगा, वरना कुछ नहीं करेगा. ओके, इट्स अ डम मशीन, इट वर्क्स एज यू इंस्ट्रक्ट इट टू डू. Then we went on to what is a program. Program is instructions. You give some instructions to the computer. So a program is a set of instructions that tells the computer what to do. Okay. तो बॉस आपको कुछ काम करवाना है, लिख के देना पड़ेगा ना क्या करना है. इंस्ट्रक्शन ये, प्रोग्राम यही है. आपने लिख दिया कंप्यूटर के लिए कि हे कंप्यूटर ये काम करो. That is what is a program. Okay. Then we came, okay, software developers are people like you and me who are writing programs that tells the computer what to do. Then what is a computer? It is a machine, so it understands only binary language. कंप्यूटर को खाली 0-1 समझ में आता है और कोई भाषा समझ नहीं आती. कंप्यूटर only understands a stream of zeros and ones. So do we give instructions in zeros and ones? The answer is no. So we write our programs in high level languages like Java, C++, Python. Okay, and we prefer Java because Java is fast, secure and portable, right? तो बहुत तेज है जावा, इट इज वेरी वेरी सिक्योर, बहुत सिक्योरिटी होता है जावा में बिकॉज ऑफ ऊ. एंड जावा का कोड आप एक जगह लिखो, कंपाइल करो और उसको कोई भी मशीन में चलाओ, वो चल जाएगा. दैट इज व्हाई इट इज प्लेटफॉर्म इंडिपेंडेंट. इट डजंट डिपेंड ऑन विच प्लेटफॉर्म यू आर एग्जीक्यूटिंग योर कोड ऑन. ओके, देन गाइस, बिटवीन HLL एंड बाइनरी देयर इज समथिंग नोन एज अ कंपाइलर और इंटरप्रेटर. कंपाइलर क्या करता है? इट ट्रांसलेट्स द हाई लेवल लैंग्वेज इनटू मशीन कोड और इंटरप्रेटर, राइट. So in Java, what happens? The high level language is first compiled to bytecode, which is very very portable. ठीक है, तो जो भी हाई लेवल लैंग्वेज होता है, यू राइट इट इन .java फाइल्स, आप कंपाइल करते हो, आपको मिलता है .class फाइल. .class फाइल को कोई भी प्लेटफॉर्म में चला दो, चल जाएगा. ठीक है, व्हाट हैपेंस व्हेन यू रन द .class फाइल? JVM होता है एक प्लेटफॉर्म पे, ठीक है. तो JVM क्या करेगा? इसको लाइन बाय लाइन इंटरप्रेट करेगा. द JVM interprets the bytecode line by line and the program will run. Okay. And after this, what did I tell you? I told you the difference between a compiler and an interpreter. The boss, a compiler compiles the entire program in one go and reports all the errors. And once you have resolved all the compilation issues, then only it moves forward, right? And executes the program. But interpreter क्या करता है? Interpreter works line by line. Okay, it will take a line, convert it into machine code and run it. The moment it finds an issue in interpreting a line, what it will do? It will stop. Okay, so generally compiled languages are faster than interpreted languages. Okay. So let's get started, guys. I think only 170 people have cast a vote. I am not sure if it's causing any problems or not, but almost 99% people are clear, so we'll move forward. Okay. Nice. Let's come here now. Okay. So now, guys, we'll be discussing a term known as algorithm. Okay. We'll discuss a term known as algorithm. So what is an algorithm, right? Now you will hear this fancy term used very, very often. Boss, my algorithm is better than your algorithm and all these things. So first of all, we need to understand what is the meaning of the term algorithm. What do we mean when I say an algorithm, right? So guys, whenever you are writing any program or whenever you write any code, what happens is you are solving some particular problem, right? So there will be different ways to solve a problem. There can be different logic that you can take to attack the problem and solve the problem, right? अलग-अलग strategy हो सकता है in order to solve a problem. What do I mean when I say this, right? So, you know what? See, what I'm telling you, let's say you have been given a problem, okay? And there can be different techniques, different logics, different methods to solve the same problem. Let's say this is logic A, this is logic B, this is logic C, okay? So basically the logic or the concept that you use or the strategy that you use to solve the problem, that is known as your algorithm. So what is algorithm? Algorithm is the steps that you take to solve your problem, right? So you will be having a particular strategy or a particular approach to solve the problem, right? And that approach that you take, the logic that you use, the concept that you use to solve the problem. Now, how do you solve the problem? There will be certain steps or certain instructions via which you solve the problem. So the strategy that you take to solve the problem or the concept that you use or the logic that you use to solve the problem, that is known as algorithm. So see, there are three different algorithms. This is algorithm A, algorithm B, algorithm C. There are three different techniques to solve the same problem, right? So what is algorithm? Algorithm in very simple terms is the steps that you take to solve a problem. Your logic, your strategy, your approach that you have taken to solve a particular problem. Now let me give you a very, very simple example to tell you. Let's suppose, you know, you want to make a sandwich, okay? My job is to make a sandwich, right? And I don't know how you guys are in kitchen, but I am very bad at making stuff, right? I can make Maggie, I can make tea, all those things are fine. Actually, I can make a sandwich as well. But for the sake of this video, assume that I am a complete dumb person who doesn't know anything about kitchen. Okay, I don't know anything. And okay? So if I want to make a sandwich, okay, the task that I have received, task, what is the task? The task or the problem that I have is that I have to make a sandwich that I can eat. Okay. And I don't know how to do this task. So what I will do? I will open up YouTube. And I will, search how to make a sandwich in 5 minutes for beginners, something like this, right? And then I will play the video and whatever steps are there in the video, I will follow that. Let's say step number 1 is take bread. Okay. Step number 2 is apply butter. Okay. Step number 3 is apply tomato. Step number 4 is apply cucumber and whatever you want, right? So these are the steps that are told in the video to make the sandwich. So I will be following these particular steps. And once I follow these particular steps, my sandwich will be ready for consumption. I can easily eat the sandwich and satisfy my hunger. So guys, what has happened? These are the steps. See, what was the problem? The problem was to make a sandwich. And what approach did you take to solve the problem? What was your strategy of solving the problem? What were the steps that you took to solve the problem? What did you do? You first of all took bread, then you apply butter, then you apply tomato, then you apply cucumber. So these were the steps that you took in order to solve the particular problem. This is your recipe, right? The recipe or the instructions or the steps that you use to make a sandwich. So these steps that I followed now, this is my algorithm. This is my way of making a sandwich, right? Take bread, apply butter, apply cucumber, apply tomato. That is my approach of solving the problem of making a sandwich. Somebody else might have a different recipe to make a sandwich, right? Somebody can take brown bread, he can apply mayo, he can grate cheese and whatnot can be done, right? So the problem is same, make a sandwich. But the algorithms or the steps or the recipe that you use to solve the problem, that might be different. So these steps that we take to solve the problem or the recipe that we, make, that is your algorithm. The steps that you take to solve the problem, that is what I, mean by an algorithm. Okay. So if somebody says that your algorithm is better than mine, it means that your strategy of solving the problem is better than my strategy of solving the problem. That is what we mean when we say algorithm. Okay. Cool, guys. So this is what we mean by algorithm. Now next, a very important thing for you all to understand is, whenever we write a program, okay, whenever we write a program, right, let's say line 1, line 2, line 3, line 4, line 5, okay, line number 1, 2, 3, 4, 5. Let's say you're writing a program and there are 5 lines, right? So whenever you run a program now, you have something known as a sequential flow of execution. Now, what do I mean when I say a sequential flow of execution? Boss, what is sequential flow of execution means? That your program runs line by line. First line number 1 will run, then 2, then 3, then 4, then 5. So whenever you run any program, you have a sequential flow of execution. Sequence mein run hota hai lines, right? So first line number 1 will run, then 2, then 3, then 4, then 5, then 6, and so on, right? So that is what we mean when I say that, boss, programs that you write, they have a sequential flow of execution. Okay, guys. So now we have understood some of the very, very basic terminologies and some basic concepts, right? So now let us come to some components of a computer program. And then we will look at our first program and we will learn some important things from there as well. Okay. So let us have a look at some of the important components of a CPU, components of a computer program, right? So you will see that there are certain important components that are present in almost all the computer programs that we will be writing, right? So what are those components of a computer program? Let us talk about that. And then we will observe or inspect one particular computer program, and then we will talk more, right? Okay. So guys, if I want to tell you about some of the basic building blocks of any computer program, right? What are the important parts of any computer program? So, algorithm, any program that you write, right? You're solving a problem. And if you're solving a particular problem, there has to be some strategy. So every program that you write, that there will be some algorithm based on which the program is written. So every program has an algorithm, right? Next, number two is variables, right? Variables are a very, very important part of your program, right? I will talk about variables a little bit more in detail, right? But think of it like variables contain data for you, right? So what I want to tell you is, see, whenever you write any program, you basically want to solve a particular problem, right? And in most of the situations, whenever you are solving a problem, you will be dealing with data. You will be operating on data, manipulating data, all these things will be done. So boss, where do you store your data? आपको अगर data use करना है, तो you need to store that data also somewhere, right? So boss, where will you store that data? You will store the data in something known as variables. So variables are also a very, very important building block of computer programs, and variables contain data. So think of variables like containers inside which you can store your data. So yes, variable is also a very, very important part of our computer programs. We'll talk about this in more details a little bit later. Okay. And the third part of a computer program is control flow or control blocks, whatever. Okay, control flow or control block. So what do I mean when I say this? See guys, in general, you have a sequential flow of execution, right? In general, we have a sequential flow of execution. That first line number 1 will run, then line number 2, then line number 3, then line number 4, then line number 5. But let's say I want to control the flow of execution of a program. Let's say I want to run line number 1, then I want to run line number 3, 4, and 5. I don't want to run line number 2. Okay, I want to have some kind of a control over how the program is getting executed. Or let's say I want to run line number 1, then I want to run line number 2 3 times. And then I want to run line number 3, line number 4, line number 5, right? I want to get some control over the flow of execution of the program. So control flow or control block are basically structures or statements that will help you to control the flow of execution of the program. Okay. So in control flow and control block, we will be talking about conditionals. Okay. And we will be talking about loops. These are the two important parts of control flow and control block. So what are these control flow or control block? They help you to control the flow of execution of a program. Boss, you don't always want line number 1, line number 2, line number 3, line number 4. You don't always want that. You might want line number 1, line number 3, line number 5, line number 7, line number 8, line number 9, 9, 9, 10, 11. So if you want some control over the flow of execution of the program, right, then we introduce something known as a control flow or a control flow block, whatever you can call it, right? And the two major parts of that are conditionals and loops, which we will talk about. So these three are the standard building blocks of any computer program. Okay. So now guys, it's time that let's go to our first Java program. In the first Java program, let us have a look at that and let us try to understand some very, very important things from that particular program. Okay. So let's move. So if you look at this program, right, this is your first Java program. This is our first Java program. And what is this program doing? See guys, this is HLL, high level language. Java is a high level language. So by looking at the program, now you can tell me what it is supposed to do. It is closer to us than closer to the computer. Dekho, system.out.print hello world. And if I run the program now, you will see that hello world is printed on the screen. Okay. So तुमको idea lag jayega. You can get an idea by looking at the program. Even if you come from a non-computer background now, you will tell me, hey Adarsh, this program is printing hello world to the screen. You can even get an idea of what the program is doing, right? So guys, this is our first Java program. And let us now try to understand some important parts of this program. And let us try to do a deep dive of this computer program. Okay. So guys, first of all, we don't go into what is public, what is class, what is main, what is public, what is static, what is void, what is main. Forget about all these things. सब कुछ भूल जाओ. What is public class main? What is public static void, right? What is this throws java.lang.exception? Forget all these things at this point of time. Forget everything. Ki boss, what is public class main? What is public static void main? String args, सब क्या भूल जाओ. We will not care about these at this point of time. Everything will be done at the correct time when the time comes, right? But what I will tell you guys is whatever code that you want to write, see, there is this public static void main. And after this, you will see a curly braces, right? Dekho guys, there is a public static void main, and after this, you will see a curly braces. So whatever instructions that you want to give to your computer, you will write it within these curly braces, right? So guys, public static void main will have a curly braces, and whatever logic that you want to write, you will be writing it inside this particular curly braces. Okay. So let's say I want to print hello world and I want to print hi. So all the logic that you will be writing, देखो, you can see these two curly braces. Public static void main का जो curly braces है ना, इसके अंदर ही we will be writing our entire logic. Okay. Now guys, one important thing is every statement in Java ends with a semicolon. Okay. So whenever you are done writing a statement, you have to end the statement with a semicolon. ऐसा सोचो guys, in English language, you end every sentence with a full stop. Corresponding, similarly, in Java, every statement ends with a semicolon. Whenever you are done with a statement, you have to write a semicolon at the end. That is a rule. That is a syntax of Java. What is syntax? Syntax is some rules of the language that you have to follow. So Java language has this rule that every line should end with a semicolon. Every statement that you write, that should terminate with a semicolon. Okay. Now, guys, now let us try to understand, forget about this. Now let us try to understand this one line system.out.println. Hello world. What is it exactly doing? So if you look at this line, guys, and see, guys, Java is a case-sensitive language. Very important. Keep making these points. छोटे points, but worth noting, worth remembering, right? Java is a case-sensitive language. That means, देखो यहाँ पे system में there is a capital S, right? So if you do a small s ना, then it will cry. Compiler will complain. Compiler बोलेगा क्या कर रहे हो भाई? I don't know what you are doing, right? So capital S is not the same as small s, right? It is case-sensitive. Okay. So system का S capital होना चाहिए. Java is a case-sensitive language. Now, guys, let us come to this. What is the meaning of this particular line, right? So see, guys, system.out.println. मतलब क्या होगा, guys? Whatever is the output of the system, whatever is the standard output of the system. See, system.out means whatever is the output of the system, print to that output. Print to that output. What will it print? Within parentheses, you put brackets here, and then within quotes, write whatever you want to get printed. Okay. So system.out.println का मतलब क्या हुआ? Whatever is the output of the system, whatever is the standard output of the system, please print to that output. Print what? Whatever you write within these double quotes, that will be printed to the screen. Okay, what is the standard output, guys? The standard output is the monitor. Okay, the screen that you are seeing, that is my standard output. So मैं क्या बोलता हूँ भाई, system.out.println, and then within quotes I write hello world. See, so system.out.println, then we will be put in brackets, and then inside we will write everything within quotes, right? So whatever you write within double quotes, whatever you write, that will get printed on the screen exactly. Okay. So system.out.println matlab whatever is the output of the system, please print to that. What is to be printed? Whatever you are writing within these brackets, right? That will be printed. So see, guys, system.out.println, you put two brackets and then you put quotes, and whatever you write within these double quotes, now that is printed as it is to your output. See, if I run this program, you will see this weird expression getting printed on the screen. Okay. See. Okay. So अभी system.out.println का मतलब clear हुआ. But guys, what does println means? Print मतलब तो समझ में आया कि print to the screen. What is println? Println means print and then move to the new line. ln stands for line. Okay. So println means print whatever is given, print that, and then move the cursor to the new line. Okay. Move it to the new line. What do I mean when I say this? Let me help you guys to understand, right? So let's say I want to print hello world. See, whatever you want to print, अभी के लिए ये समझो, you will have to put it inside double quotes, right? So आपने लिखा system.out.println, you put brackets and then you will put quotes, and within these double quotes write whatever you want to print to the screen. Okay. Now let's say again do a system.out.println. Yo, how are you all doing? Now guys, what is the exact meaning of println, right? See, system.out means whatever is the standard output of the system, उधर जाके करना है आपको काम, ठीक है? So boss, whatever is the output of the system, please print to that and then move to the next line. Println means print the contents and then move to the new line. Okay, what do you want to print? You want to print hello world. So see what happens. Let's try to understand. Let's first run it and see. So we will see in the output that hello world and yo, how are you all doing? These are printed in two different lines, right? They are printed in two different lines. So what actually happens in println? Let us try to understand that. Okay. So guys, see, what happens is, let's say this is my screen, right? I'm emulating the screen, right? So my cursor will be here. There will be a cursor here, right? Ab kya hoga? I'm saying system.out.println hello world. So hello world will be printed in this line. Okay. And after hello world, the cursor is at the end of the line, right? But because you have used a println, what does println say? Print the contents and then move the cursor to the new line. Okay. So after hello world is printed, this cursor will move to the new line. Dekho cursor aa gaya nayi line. Okay. Then you say again system.out.println, yo, how are you all doing? So what will happen, guys? Cursor idhar hai. So yo, how are you all doing will be, after printing this contents, the cursor will move to the next line and your program terminates, right? So see guys, first of all, my cursor was here. I did a system.out.println hello world. So hello world was printed in this line and then the cursor moved to the new line. Println matlab print and then move the cursor to the new line. Next the cursor came here and what was the next line of code? System.out.println, yo, how are you all doing? So yo, how are you all doing was printed in this line because the cursor was here, right? Cursor print कर रहा है, cursor comes at the end of the line, and because there is a print and the cursor will move to the next line. Okay, and then because there are no other lines to be executed, the program terminates, or the program basically stops. So guys, cursor जहां पे होता है ना, वहीं पे हम लोग print करते हैं, right? So try to understand. Initially your cursor is here, so you start printing H E L L O W O R L D. After the cursor has printed all these things, the cursor comes to the end of this line, right? And because you have used a print ln, now after printing D, the cursor will automatically move to the next line. So whatever things you print here, now they will be on the next line, right? So now what will happen? Yo, how are you all doing will be printed in this line. And because you have a print ln here also, after printing all these contents, the cursor will again move to the next line. So print ln क्या बोलता है? Print the contents and move the cursor to the next line. ln is basically for moving to the next line. Okay. Now let's say that I add something like this. Print system.out.print. So what does it say? Whatever is the standard output of the system, print there. But after printing, the cursor will not be moved to the next line. Okay. जब मैं system.out.print बोलता हूँ ना, so the cursor does not move to the next line after printing. So guys, can anybody help to guess the output here? I've opened up the chats. Can you guess the output here? Anybody? Yes, guys. Anybody output? Same line, side by side. Okay. So let's see. Let's try to run it and first understand. No error तो नहीं होगा by error. Print is also valid, right? ऐसे जैसा print होता है, print भी कर सकते हो, ठीक है? So see guys, see, hello world, and then you have yo, how are you all doing? Everything has appeared on the same line. So let us try to understand what has happened in this particular case. So first of all, guys, the cursor was in line number 1. The cursor is here, right? Now what happens is system.out.print hello world. So hello world will be printed, but because you have a print, after printing hello world, the cursor will not move to the next line or the new line, right? So H E L L O W O R L D. The cursor prints all these characters, and then the cursor is standing at the end. After D, the cursor is standing here, right? ये next line पे move नहीं किया because you don't have a print ln. After printing hello world, cursor is standing here. Okay. Now guys, you come to the next line here. Next line of code, what is it? System.out.println. Yo, how are you all doing? So because the cursor is here, cursor क्या करेगा boss? देखो, ये print करेगा and then it will move to the next line. So from here only, the cursor is here now. So from here only you will see getting printed. Yo, how are you all doing? And after this is printed, the cursor will move to the next line. Why to the next line? Because here you had a print ln. So see guys, first of all, hello world was printed. And because you have used the system.out.print, the cursor does not move to the next line. So the cursor was here. Okay. And then you came to here, this line is executed. System.out.println. So yo, how are you all doing will be printed. Where cursor इधर है ना, तो इधर से ही print होना start होगा. See, without any gaps. The cursor was just after D. So from here only printing happens. Yo, how are you all doing? And after printing this, because you had a print ln, the cursor will move to the next line. The cursor comes here and then the program terminates. Okay. So guys, I hope you all understand the difference between a print versus a print ln. Print ln says print and then move the cursor to the new line. The cursor will go to the new line. And if you use only print, the characters will be printed and the cursor will not move to the new line. Okay. So is this making sense, guys? What I'm trying to say. Let's see. Yes. Okay. Can anybody help me with the output of this? Yes, guys. Can anybody help me with the output? Did you see them in separate lines or in the same line? Did you see them in separate lines or in the same line? Different lines, right? They will come in different lines, right? Let us try to see how. Okay. They will be in separated lines. Only what will happen is after you print the second line, the cursor will not move to the third line. Right? That is the difference. So see guys, what happens? The first line that you print is system.out.println hello world. So hello world will be printed in the first line, and then because you had a println, the cursor will move to the new line. Okay. Next, what do you say? System.out.print. Yo, how are you all doing? So because the cursor is here, yahin se print hona start hoga. Yo, how are you all doing? And after this, the cursor will be at the end of this line, right? And the program terminates, right? Because there are no other lines. So boss, you are seeing the output in two different lines, okay? But just so that because you have used a print here, now after printing, the cursor doesn't move to the third line. It remains at the end of the second line only. So hopefully, guys, you now understand what do I mean when I say system.out.print, okay? And within brackets, you will put double quotes and write whatever you want to print to the screen. So hopefully now you are clear with the difference between a system.out.print versus a system.out.println, okay? Now, another thing, guys, there is another way of moving your cursor to the next line, right? So what happens is, I'll tell you, there is another way, right? So you can do like this also, system.out.print hello world. And after this now, you put a backslash and then you write n. You write this backslash n, right? This backslash n actually indicates that you need to move your cursor to the new line. Okay. So मैं क्या बोलता हूँ, guys, see, the reason I'll tell you, right? If you just write an n here, what will be printed? Hello world n, right? तो मेरे को कंप्यूटर को बताना है कि boss, the n that is coming, that has a special meaning. move the cursor to the next line. So first of all, I put a backslash, right? This backslash tells me that whatever character is coming next, that has a special meaning. Don't treat it like a normal character. Okay. So backslash bolo isko ya kya bologe pata nahi. Backslash and it actually means I want the cursor to go to the next line. So what is this backslash, guys? This backslash is an escape character, escape sequence, right? I'll tell you. This backslash, we call it as an escape sequence. Okay. Escape sequence. Why? Because ye bolta hai, boss, whatever character is coming next, na, don't treat it as a normal character. That has a special meaning. And when I write n after a backslash, na, it means that move the cursor to the next line. So what will happen? Hello world will be printed. Okay. Hello world is printed. And after hello world, what is there? What is printed? Backslash n. So when you print backslash n, actually you are telling to move the cursor to the next line. Okay. So देखो हम लोग ऐसे भी नीचे भेज सकते हैं system.out.print, but inside this write hello world and then backslash n. So this backslash n will basically move your cursor to the next line. So guys, try to understand. If I do something like this, let's see how many of you understand. What will happen, guys? Anybody, can you guess? Hello W will come on the first line. Then you have a backslash n, so the cursor will move to the next line. And then ORLD should be coming on the next line, followed by this yo, how are you all doing? Let us try to run it and see. Okay. So I'm just telling you a different way. How, where is my cursor? 1 second. See guys, what has happened? System.out.print, so hello W is printed, then you have a backslash n, so automatically the cursor moves to the next line. Then ORLD is printed, this line has been executed now, and the cursor is standing here. See. After this ORLD, cursor is standing here, right? Then you have system.out.print, you, how are you all doing? So from here only you, how are you all doing will be printed, and then the cursor will be at the end of this. Okay. So backslash n is just another way of moving the cursor to the new line. This is the new line character, backslash n. And what is backslash? Backslash is an escape sequence or an escape sequence character, right? That tells you that boss, whatever character is coming next, that has a special meaning. So backslash ke baad yadi n likhoge, so it is like sending the cursor to the new line. But okay, we generally don't use this a lot. We generally do it via print ln only. कि अगर मेरे को प्रिंट करके नेक्स्ट टाइम में भेजना है तो प्रिंट द कंटेंट्स एंड प्रिंट ln will basically move the cursor to the new line. Okay, so this is what is, you know, the difference between a print and a print ln. Okay, okay guys, so are we all clear till here? Also on data, right? So let us try to understand what are some mathematical operators that you should all be knowing about. Okay. See, backslash n is something that tells move to the new line, right? Backslash के बाद any character रखने से कोई अलग result हो सकता है, right? Let's say backslash t, right? This basically is equivalent to hitting a tab. ये बोलता है give a tab. Okay. So different characters will have different meanings, right? Backslash n basically means move to the new line. Okay. Any time to join in morning? No, Manisha, I don't think we have morning sessions at the moment, but all the classes are recorded. So if you are more comfortable in attending or, you know, watching the recordings in the morning, that's also fine. You can do it. But yeah, live का अलग flavor होता है, recording का अलग flavor होता है. Whatever you guys are comfortable with, right? I don't have a problem. Okay. So where were we? Yeah, we were talking about certain mathematical operators. Okay. Let's try to think of some, you know, operations that we can perform on some data, right? You know, what all operations that we can perform on some data. But before going to this, guys, I think there is one thing that we want to discuss, and then maybe we can give a break. Time is 9:40, right? So let's discuss that thing, and then we can go into a break. And when we come back, we will talk of operators, variables, and other important things of our program. Right? So what I want you guys to understand is, you know, I know that the class might not be very structured because the problem is I don't remember the order properly. ठीक है, मेरे को भी बीच में देखना पड़ता है कि क्या पढ़ाना है. ठीक है, I forget what are the points to cover. So it might be जैसे जैसे मेरे को दिमाग में आ रहा है, I'm just covering it, right? So little bit it might look like unstructured, but again, if you follow, it will be simple to understand, not that difficult, right? So two important components of a computer that I wanted to talk about earlier, but I forgot, right? So the first component that you should all be aware of is a CPU. What is a CPU, guys? CPU is your central processing unit. Okay, we'll come to operators a little bit later, right? So CPU is your central processing unit. Okay. So what is CPU? Think of the CPU like a brain of the computer. What is CPU? CPU is your brain of the computer, right? CPU is responsible for all the fast calculations or all the computations that happen, right? CPU is responsible for that. Okay, it's the brain of the computer, and it is responsible for performing all the fast calculations that a computer is able to do. So the entire computation power that lies within the CPU. Okay. And you know what? CPU, what is the CPU? The processor. Okay, when you see on your laptop, right, you might see an Intel Core i5, something like that, right? So these are all processing units. These are processors that actually give you the computation power inside your computer, right? And the CPU actually consists of something known as an ALU, registers. These are all present in the CPU. What is ALU? ALU stands for arithmetic logical unit or arithmetic logic unit, something like that, right? So ALU and registers help us to perform all these computations, additions, subtractions, and all these complex operations, right? So long story short, what I want to summarize is, boss, your CPU is like the brain of the computer, responsible for all the fast or the complex computations that happen. Okay, so this is one very important component of a computer that all of us should understand. What is the next important component, right? The next important component that I want to talk about is storage. Storage, right? What was the second good point of a computer? The first good point was it has good computation power, right? And what was the second good point? The second good point was that yes, a computer has memory. Okay, can store important information, right? So guys, the memory of a computer, that has two types. There are two kinds of memory in our computer, right? One is your primary memory and the other is your secondary memory. Okay. Now your secondary memory is ROM, read-only memory. ROM is a part of your secondary memory. Or think of it like SDD, the hard disk that you have, right? The SATA disk drives that you have. SDD हो गया, HDD हो गया, all these hard disk drive होता है ना जो, these are all secondary storage or your secondary memory. So ROM, hard disk, SDD, these are all examples of secondary memory. Okay, and these are large in size, right? If you see, you can see 256 GB, 1 terabyte, all these things, right? This is large. What is your primary memory? See, whenever I talk of memory in the class now, 99.99% cases of the time, I will be referring to the primary memory, because the primary memory is of more importance too when we run the programs, right? So guys, what is your primary memory? The primary memory is basically your RAM. So whenever I talk of memory, I basically want to talk about the RAM, which is a part of my primary memory. So what is the full form of RAM? Random access memory. Okay. So this is your primary memory, and the size of the RAM is generally 8 GB, 16 GB, 4 GB, 32 GB and all this. But yes, the primary memory is responsible for running the program, right? So whenever we talk of memory, we will be talking of, the primary memory only. Okay. So guys, how does the RAM actually look like? अगर मेरे को एक simple सा representation देना है, if I want to give you a very clear picture of how does the RAM look like, a very simplified picture, right? So think of your memory like a two-dimensional grid. देखो बनाता हूँ. Please forgive my drawing, guys. My drawing is not that great, and I don't really want to spend much time perfecting my drawing. Okay. So, guys, you can think of your RAM to be like a two-dimensional grid. Simple, so your memory is like a two-dimensional grid, right? And in every cell that you see now, you can store some information. You can store some data. Okay. Now, in your city or in your town where you are living, right? There are multiple houses. अगर मैं तुमको एक street view दूं, there are multiple houses in a street. So how do you identify a particular house? You have the address. Okay, you have a house number. You have a floor. By all these identifiers, you are able to identify or locate a particular house. Let's say if I give you a satellite image of your town, right? There is a house here. There's a house here. House. How do you identify a particular house? Every house will have a unique address. And using that address, and when I talk of a unique address, right? ऐसा मत बोलना, hey, my neighbor also has the same address as me, right? A unique address means your address with your floor, with your name, right? These are unique, right? So every house you can identify by a unique address. So similarly, what happens, guys, is your memory is like a two-dimensional grid, and in every cell you can store some particular information, some amount of information you can store. And how do you identify a particular cell? Every cell in memory has an address. There is an address assigned to every particular cell. So using the address, you can identify the location of your memory. Okay. Now, I want to talk something about the units of storage, right? How much memory how much amount of data you can store in a particular cell? Let's talk about that. Okay. So guys, as you know that all the information or all the things that a computer understands only in zeros and ones. So whatever instructions or whatever data will be stored in the RAM, that is somehow in the form of zeros and ones only at the end of the day, right? So guys, what happens is in binary language now, every digit is a binary digit, right? Either it can be a 0 or it can be a 1. A digit can be either a 0 or it can be a 1, right? It's a binary digit, right? So a binary digit we basically call as a bit. Usko chota kar dete hain. Every digit in the binary language is a binary digit. Either it can be 0 or it can be 1. And we call a binary digit as a bit. So what is a bit, guys? A bit is a digit that can either be 0 or a 1. So see, guys, the data that I have written here, 0, 1, 1, 0, 0, 1, 1, 0. How many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bits of information, right? See, the first bit here is 0. Then this bit is 1. This bit is 1. This bit is 0. This bit is 0. 1, 1, 0. So there are 8 bits. This is 8 bits of important information, right? So one binary digit. Okay, so I will tell you like this. The amount of space that you need to store one binary digit, that is known as a bit. So the amount of space that you need to store either a 0 or a 1, that is known as 1 bit. Okay. So guys, what is the unit of storage? the unit of storage is bits. Okay. So if I say that, boss, I have 4 bits of space, that means you can store 4 bits of information. Okay. So bits is basically the unit of storage. You can measure how much data you can store via bits. Okay. But bit is a very, very small unit of storage, right? Because whatever data you store now, that will be thousands of bits. Maybe there may be large number of bits will be there in the data, right? So guys, a more practical unit of storage is, what do I say? See guys, 1 bit is either a 0 or 1, right? So we say that 8 bits make up 1 byte. 8 bits make up 1 byte, right? So see, if you look at this 011001110, right? This is 8 bits of information. So I can say that this is 1 byte of data. 8 bits make up 1 byte. Okay. Then similarly, you will see 1024 bytes. Okay. Or we simply say 10 to the power 3 bytes make 1 kilobyte. 10 to the power 3 bytes will make 1 kilobyte. Similarly, 10 to the power 6 bytes will make 1 megabyte. Similarly, 10 to the power 9 bytes will make 1 gigabyte. Okay. So these are the more commonly used units of storage, right? You will see somebody will tell you, hey, my hard disk can store 256 GB of information. Okay. So now you will understand that if I tell you, hey, my primary memory is 8 GB in size, what does it mean? I can store 8 gigabytes of information. Okay. So what is 8 gigabytes? 8 into what is 1 gigabyte, guys? 1 giga is 10 to the power 9. 10 to the power 9. So 1 gigabyte is 10 to the power 9 bytes. Okay. So 8 gigabytes is 8 into 10 raised to the power 9 bytes. And 1 byte is 8 bits. So it is nothing but 8 into 10 to the power 9 into 8 bits. So this much amount of data you can store in 8 GB. What is 8 gigabytes? 8 gigabytes is nothing. What is 1 giga? 1 giga is 10 to the power 9. So 1 GB is 10 to the power 9 bytes, right? So how many bits in 1 GB? 10 to the power 9 into 8 bits, right? Because 1 byte is 8 bits. So how many bits can be stored in 8 GB? 8 into 10 to the power 9 into 8 bits. Okay. So the more commonly used units of memory will be MB, KB, GB, right? Because bit is a very, very small unit. Okay. But yeah, you understand that the amount of space needed to store one, 0 or a 1, a binary digit, right? That is basically a bit. Okay. And कुछ लोग ऐसा भी बोलते हैं, not very frequent use, but 4 bits make a nibble. Confirm this, I'm not 100% sure, but I remember it. 4 bits make up a nibble. 1 nibble is 4 bits. Just confirm this once, cross check also if you can. Okay. So 4 bits make a nibble. Okay. So, 1 second. Okay, we have 10 minutes still left. Not a problem. Okay. So, guys, 1 second. So, if I tell you, boss, in every cell here, you can store 1 byte of information. Let's say I tell you, in every cell here, you can store 1 byte of information. That means 8 bits of information can be stored in this particular cell. So in this info 0110, 0110, 8 bits of information you can store in this particular cell, right? So that is how memory looks like. And that is what we mean when I say a bit or when I say a byte, KB, MB, GB, all these are nothing but units of storage. Okay. And ultimately everything boils down to bits, zeros and ones. That is what is getting stored at the end of the day, right? So that is something about RAM that I wanted to tell you. Okay. Has everyone followed me till here? Yeah, it's such a simple representation of a RAM, right? Not going into very complex details, not needed. Okay, guys, cool. So, where were we? We have 10 minutes, right? I'll give you a break exactly at 10 o'clock. It's 9:52. So we have 8 minutes of time left, right? So let's just, where were we? Where was operators? Okay, let's write operators once again here. Not a problem. So guys, we're talking about operators, right? We might not be able to solve problems today, okay? But I think it's important to lay the foundation so that, we can spend some time tomorrow also on solving problems. That's not a problem, okay? So operators, right? You can perform certain operations on your data. First of all, you will have data. So what are the operations? What are some basic mathematical operations that you can perform on your data? So you can add your data, subtract, multiply, divide, okay, and then there is a modulo operator. So let us try to understand the meaning of all these operators, right? And for all practical purposes, we are talking about numbers, integers, right? Pure numbers, right? Integer, not fraction or not any other thing, right? Pure integers, right? So you can use a plus sign to add 2 numbers, right? So 5 plus 5 will give me 10. Similarly, the minus operator, it subtracts 2 numbers, right? So if I do a 6 minus 5, you will get a 1. Okay. Similarly, if you do, use the star, it is basically multiplication. So you can multiply 2 numbers also together, right? Now, the interesting part comes in division and, this percentage. What is this thing, right? So guys, whenever you divide 2 integers in computer, right? जब भी आप लोग divide करते हैं 2 integers को, it is a floor division. It is a floor division. What do I mean by say? Let's say I tell you 8 by 5. Okay, let's say whenever we are dividing 2 integers now, it is a floor division. In general maths, 8 by 5 would have given you a 1.6. But in computers, you will see 1. How? See guys, you are dividing 8 by 5. So what is the quotient? 1. And what is the remainder? 3. So 8 by 5 gives you the quotient part. Whenever you use the division operator now, you will always get the quotient part, right? So it is a floor division. What do I mean when I say a floor division? See, 8 by 5 would have ideally been 1.6. Is my maths fine? 1.6 types yoga, hai na? So 1.6 is rounded down to the nearest integer, that is 1, right? So it is a floor division. So whatever answer you get, that will be rounded down to the nearest integer. Floor pe jayega wo apne, right? So 8 by 5, whatever you get in the quotient, that you will get as the answer. Okay. So be very careful whenever you do division of two numbers because it is a floor division. Okay. So whatever you should be getting, that will be rounded down to the nearest integer. Okay. Or more simpler way to understand is 8 by 5 kiye. So whatever you get in the quotient, now that part you will get as the answer. Now you will ask me, how do I get the remainder? If I divide 8 by 5, the quotient is 1 and the remainder is 3. How do I get the remainder? And that is where I introduced to you the modulo operator. Ye jo percentage dikhaya tha na, this percentage is known as the modulo operator. Modulo. Okay. This is your modulo operator. So what does it do, guys? It basically gives you the remainder. So if I tell you 8 modulo 5, iska matlab pata hai kya hua hai? When you divide 8 by 5, what is the remainder? So this will give me the output as 3. Okay. So the modulo operator or the percentage operator, that gives me the remainder. So when I divide 8 by 5, what is the remainder that I will get as the answer? Okay. Now let us quickly try to use these operators in action to see whether they are working. And after that, I think we'll go into a quick, break kind of a structure for 10 minutes, right? So let's say I want to print something, right? So guys, whenever you are doing these numbers now, you don't need to put quotes, hai na? Quotes daloge na. Let's say if you do quotes, right? So what did I tell you? If you write something within double quotes, now that is printed as it is to the screen, right? See, if you write within quotes 10 plus 5, then you will see exact 10 plus 5, aisa ka aisa print ho jayega. Dekho, 10 plus 5, okay? I'll just write a print ln here so that you can see it on a different line. You will see this 10 plus 5 is printed as it is. So if you write anything within double quotes, now that will be printed as it is to the screen. So if you really want to perform operations, what we have discussed, right? Don't write quotes. Within brackets, just write whatever you want to do. Let's say 10 plus 5. Okay, मैं थोड़ा बहुत करके बता देता हूँ. Okay. Then let's also do a 10 minus 8. Okay. Then we can also do we are just performing operations, right? 10 into 6. Okay. And then we can also do a 10 by 3. Okay. And we can also do a 10 modulo 3. Okay. Okay. So what are we expecting? First of all, see, because it's a sequential flow of execution, first hello world will be printed, then how are you all doing will be printed. Then 10 plus 5 is 15, so 15 will be printed. Then 2 will be printed. Then 60 will be printed. Then 10 by 3. What is 10 by 3, guys? 10 by 3, the output should be 3, right? Because when you divide 10 by 3, in quotient you get 3 and in remainder you get 1, right? So this will print a 3 and this will print a 1. Let's try to run it and see. So these are some basic mathematical operators which you need to be very, very clear about. Let's see, guys. First, hello world. Then how are you all doing? Then you see 10 plus 5 is 15. See, now the actual operation has taken place and you get the output. 10 minus 8 is 2, 10 into 6 is 60, 10 by 3 is 3, and 10 modulo 3 is 2. So hopefully, guys, you understand these basic operators, right? These basic operators, plus, minus, into, divide, and modulo. And it's very important that you understand that division is a floor division. Okay? Cool, guys. Are we clear till here? Let's see. I've allowed you to chat. Okay. Why have you written 8 binary digits in the same block? Because I assume that one block can store 8 bits. Okay, that is why I 8 byte pura likh diya. And I just assume. Okay.